Session 2D, editing your slicer recipes and slicing your STL. Begin. Now that we've got our model scaled, positioned, and rotated how we want, we're going to examine our recipes and see if we want to use a prefabricated recipe that we send out with the printer, or if you want to make some modifications yourself. If you want to select existing recipes, you can pick the recipe that you want. And go ahead and slice. Process slice with slicer. However, if you want to tweak the recipe or adjust it to your needs, you can click on the Edit Recipes button. This will launch the Slicer configuration tool, which just takes a few seconds to launch and be captured in the Slicer tab of the left side of the Repetrel program. And there it is. So, in your configuration options here, you have print, printer, and 4 extruder recipes. Now, likewise, in the slicer window, you have your print settings, your filament settings or extruder settings, and the printer settings. The one you're going to change most is going to be probably your print settings. Let me start here. This is our default recipe, and what this means is it's a 0.5 millimeter path width for the 0.5 millimeter nozzle. It's 0.2 millimeters or 200 microns in the Z each layer. My feed rate is 30 millimeters a second or 1800 millimeters a minute, and I'm going to use a 35% hexagonal or honeycomb infill. And we can look at all these options, and that's just listing the most commonly changed options, but there are many pages of data here. So page 1, layers and perimeters, I'm telling it that I want the first layer to be at 200 microns or 0.2 millimeters, and I want all the other layers to also be at 200 microns. I'm going to tell it that the vertical shells, now that means each horizontal cross section that you make, how many solid perimeters are going to be exposed to the air on the left, right, front, and back. And I'm going to set this to 3. I don't want to use spiral vase mode because that'll force me to 1 perimeter and no top and no infill. That's something, if you want to do one of those hollow vases, you can check that. For horizontal shells, I like to have more solid top layers than I do on the bottom because I'm going to use a less than 100% infill, and I want to give those top layers a chance to solidify up. The first one's going to have a little sag. It's hard to avoid. But by the time I get the 5th layer on, it should be nice and flat. I leave all my quality options selected. I like to have a random seam position. This way every layer change happens at a different point. However, some people like to use an aligned seam position, and then they only have one place if they want to do some post-processing to sand it down or something. There's only one place to look. And we like to do internal perimeters first because if there's any overhang, we want there to be more material for that perimeter bead to adhere to. The slicer's got a lot of great tooltips, so if you just hover over or click in any field, a tooltip will jump up and give you more detail on that variable. The next page is infill. You can pick or type in whatever infill density you want. Note that some patterns will not work with 100% infill, like the honeycomb. We like the honeycomb, so we're going to do 35% density. That's a good compromise between how long it takes to print and how structurally strong the piece is. A variety of infill patterns. We like the honeycomb pattern. And you can use a different pattern for top and bottom. We like to use a rectilinear pattern because at a 45-degree offset, because it's easier to make their line just a little bit longer, and if you have an odd shaped gap, you don't want to have the zigzag infill. It vibrates the equipment a lot and doesn't always give you a good quality output. I don't really change the reduced print time stuff, and like I say, we use this. At the offset, the degree rotation for the infill doesn't matter on the hexagonal or the honeycomb, but for the rectilinear, there's really no point in doing your infill parallel to the front or back or left or right side, so I do that at 45 degrees. And these are checked. We don't do any G-code based retract because the way the Hyrel equipment works, it doesn't process that the way other printers do. In our firmware, based on our print head settings, we determine when to advance and retract to prime and unprime based on what the G-code has just done and what it's about to do. And we don't use these numbers, so that can actually, if you have the wrong prime and unprime or advance and retract settings set in your recipe, you can actually reduce the quality of your print. For skirt and brim, this is a version of support material. A skirt are just a couple of loops that you see outside your model. It's a final check that we do to make sure that the material is flowing properly, that it's sticking to the bed, and that it doesn't look like it's thicker on one side than the other. That would tell us that the bed's not exactly level. And the brim is an extra bit of material on the first layer only that surrounds your model and gives it extra surface contact so that you have better adhesion to the bed. We recommend using a brim on most models for your thermoplastics. For clays and emulsifiables, you don't need any of that. Support material. For this recipe, we're not going to use it. If I did want it, I would just check this box. Our overhang threshold is 35 degrees. So we're good down to a 45-degree overhang, and even more shallow, more horizontal than that, down to 35 degree. If you have a more shallow overhang than that, you want to consider support material. We don't like using a raft, but you can if you want. And if you have a bridge of a centimeter or less, there's no need for support material for most filaments. But if you have like a 4-inch span that's bridged, you want to consider using support material for that. And these are the settings that we find work pretty well for ABS and most materials we print with that require support. But we prefer to design our parts so that they print without support, or in a rare case build in support to the STL so that it's only where we know we need it, and then we can just trim that one piece off when we're done. But for today, we're not going to use support. The speed, we don't recommend running the printer at more than about 2 meters a minute. So our default recipes indicate 30 millimeters a second or 1800 millimeters a minute. For some materials and some G-code, based on how the printer is moving, we actually recommend going slower. If I'm printing with porcelain, I normally print at we print about 50 or 40 millimeters a minute. So that would be at 10 or 12 millimeters a second, or less than that even. Maybe 10 millimeters a second is 60 millimeters a minute. Something like that, or lower for porcelain and more dense, more viscous materials. And also material that is not going to set up as it's deposited. It needs to be fired, and you don't want to wiggle it too much as you're printing. And I don't see any benefit mostly from going at different speeds at different parts of my print, so I tell everything to go at the same speed, but you're welcome to experiment with that. For today, we're just going to use one extruder. However, we'll go into future videos about how you can use one extruder for your perimeters, a different one for your infill, another one for your solid infill, or your support material and your support material interface if you have support material checked. We'll go into that in the future. For today, we're going to do everything from extruder number 1. Another benefit from this is that we're not going to ever specify in our G-code which head to use. So you can run the same G-code with your head loaded in slot 1 or 2 or 3 or 4, and it's going to print it with the head that it finds. The last head that it locates is the head it's going to use, unless in your G-code you specify a particular head. Then you have to configure your machine to match your G-code, or edit your G-code to match your configuration. The advanced option, what we mostly care about here is the extrusion width. I like to use the same extrusion width for everything, and it should be 10% wider than your nozzle is, because as your material exits the nozzle, it's going to hit resistance either from the glass build plate or the layer beneath it, and it's going to spread a little bit. This gives us the best results. We use a 0.55 millimeter path extrusion width for the 0.5 millimeter nozzle. When I do 35% infill, we like to have a 15% infill to perimeter overlap. This ensures that the infill part actually touches the outside perimeter walls. If you're doing 100% infill, you don't want any overlap. And on some densities, you may want to experiment with that and change it. But we find that this works great with these recipes, 15%. And we don't change the other stuff in it at all. Our output options are basic. We use the verbose G-code just so that you can read it as a human being and understand what the lines mean without having all those commands memorized. We don't have any notes. If I'd made any changes I wanted to save, I click on the save icon and I give it a new name, like maybe this was going to be a 25F recipe. I could make it a 25 feed rate or a 10 or whatever, but I'm going to cancel because I didn't make any changes. For filament settings, all we care about here is the heating and cooling. So what we care about, this is our 240 degree recipe with a 25% fan. So I'm going to have the extruder set to 240 degrees for the first layer and all the rest. and I'm going to have the bed set to 80 degrees, and it may reach that or it may max out at 75 or 76, depends on the room temperature, the ambient temperature. And I want all layers at the same temperature. I don't care about the extrusion diameter. This is useful for calculating how much filament you're going to use, but we do not use this in any way for our flow calculations. So this, I've run the exact same G-code with this set to 100 and set to 1, and I get the same exact prints. The other page is cooling. We like to have the fan for most filaments always on at 25%. Now you'll see that this says 10%. That's because Slic3r is going to multiply this number by 2.55 because I can't tell you. Other stuff uses 0 to 255 as a value, but when we did our software, we told it to run it between 0 and 100. So if I put a number in here, if I put 50 in here, it's going to generate a recipe to run at 250, and it's not going to be read right. So this will come out to be 25.5% in my actual G-code, and it'll be just right. Some people like to use auto cooling, and you get a complicated algorithm of at what time to speed up the print, slow down the print, ramp up the fan, ramp down the fan. And that confuses people because if they start this and then they manually adjust the fan down, they get frustrated when the next G-code command tells the fan to be at a different speed, and it's like their change never happened because it's not persistent. With this setting, there's going to be no fan command until after layer 5, and then the fan's going to come on at a set speed. If you jump in there at layer 30 and bump the fan up or down, it's going to stay like that till the end of the print. Last is the printer, and if you're using an emulsifiable, you're going to want to use like a no heat, no fan setting that just doesn't turn it on. I have this setting the bed to 30 degrees because the plasticine I test heads with does better if the bed's a little warm, but there's no cooling fan on that, and there's no heat on the EMO or SDS heads. The printer settings, there are two basic recipes that will come with you. The heated head recipe has got a command here on the custom G-code page that says wait for temperature to come up. If you slice with an unheated extruder and you have this line here, your print will never start because that head is never going to tell the bed, to tell the Repetrel program that it's reached 0 degrees or any degrees because it doesn't report temperature. So the only difference, if we go to the unheated head recipe and we look at the custom G-code page, that line is commented out with a semicolon. In your G-code, on each line, anything following a semicolon is just a comment for you to read. It's not going to be executed by the machine at all. We can look now also at our end G-code that just has some safety things. It turns off the motors and the heaters and drops the bed out of the way and moves to home. We have some before layer change G-code, just announce the layer height and also any new layer actions like using the camera. And we don't have any specific change at this point for the after layer change or for a tool change. When we do a tool change, we'll automatically do, based on the data stored on the head, a number of unprimes after we print and a prime or advanced moves before that head prints again. And you can specify a variable for just a tool change, and you can specify or a variable for just between printing and non-printing moves, and more iterations of that same variable multiple times if you're doing tool changes because your head may be sitting idle for several minutes. For the extruders, we don't want any retraction distance specified in here. We don't care about the nozzle diameter because we don't use that number, and we don't use the extruder offsets. We store that data on the extruder. So these should all be set the same, except the diameter doesn't matter. And on the general page, these are all preset. We use a Repetrel version of the G-code flavor, and the rest of them just as you see it. You shouldn't have to change these, just pick either unheated head or heated head. If you make any changes and save anything, they won't populate here until you close this window. That'll force them to reload these, and now if you had saved a new recipe, you could select it at this point. I've got this model, I've got these 3 recipes, and since we don't specify any extruder, it's only going to use the recipe shown in extruder 1 because it's only going to use the first extruder it finds. I'm going to go process and slice with Slic3r.